Okay, the rate at which rainwater flows into a drain pipe is modal. So into is R, and given that, cubic feet, and the water drain out is given that. So R is going in and D is drained out. So A, how many cubic feet of rainwater flow into? So we don't really care about D here. And interval 0 to 8, then all you have to do, use your calculator, integral 0 to 8 of RT dt, and you will get 76.570. You might have questioned with, okay, how many decimals do I need? Then I recommend you to put up to 10 thousandths place. So 3 decimals after the decimal point. Letter B, is the amount of water in the pipe increasing? So it's asking, is RT greater or DT greater? If RT is greater, then going in is more. If DT is greater, then draining out is more. At T is equal to 3. So for letter B, you plug in R of 3 and compare that with D of 3. And if you have plugged in correctly using your calculator, you will get their difference. So R of 3 minus D of 3 is a negative value. What does this tell you? That this is smaller and this is bigger. Therefore, water being drained out is more, since D3 is greater than R3. So you write down D3 is greater than R3, therefore more water is drained out. Or no, we have to be more specific than that. We'll say the amount of water is decreasing. Letter C. At what time T 0 to 8 is the amount of water in the pipe minimum? Okay, you're looking for the minimum value. It says there originally were 30 cubic feet of water at T is equal to 0. But that's not really important at the point. We're looking for when it is the minimum. So we know minimum occurs at its critical point. And critical point occurs when rate is equal to 0. We're given two different rates, rate going in and rate going out. And if you find the difference, that is going to be our water level rate. Amount of water changing. And we want this to be 0. And use your calculator again. You will get a critical value at T is equal to 3.27. And how you do that is simple. Plug in Y1 as RT and Y2 as DT and Y3 as Y1 minus Y2, and graph Y3 only on your calculator, and you will see either it's changing from positive to negative or negative to positive, but you will get your critical value at 3.27. Then at T is equal to 0, your water is 30. That's your beginning value. At T is equal to 3.27, if you do integral 0 to 3.27 of RT minus dt, then you will get a negative value. So you will see water level goes down, therefore this is your minimum, since this is your critical value. And at t is equal to 8, if you do the integral from 0 to 8, then you will get a positive value, about 18.5. Now letter D is asking, so answer will be 3.27. And it says justify your answer. You will justify it by showing this is less than 0, so your water level is going down. And you'll also write that at critical point, you will possibly get relative minimum. The pipe can hold 50 cubic feet of water for t is greater than 8. Water continues to flow into and out of pipe. So you write, but you don't solve, an equation involving one or more integral that gives the time w. Then you will do, okay, we originally started with 30 plus 0 to time w of RT minus dt, and we want that to be 50. And this is your answer for letter D.